Let's just put some numbers to it. So a rod hinged at one end has a length of 3 meters. A 65 Newton force is exerted at the end of the rod at an angle of 30 degrees as shown. Calculate the applied torque. So we're just trying to find out the torque caused by this force right here. So this is some force, and we know this is 3.0 meters from the pivot all the way to the force. So this is our pivot point. It's rotating around this point. So it's a pretty straightforward calculation. We have force perpendicular is equal to, so when we look at this, be careful how the angle is drawn. In the previous question we drew it like this, and I gave you this angle. So you can see it's sine. But based on how I drew this picture, the perpendicular component, here, right here, Fy, that is going to equal to our force 65 newtons. In this case, it's going to be cos 30 degrees. Again, we could have just as easily written this as 65 newtons sine 60 degrees, because cos 30 and sine 60 is the same. So you find out force perpendicular is equal to 56.292 newtons. And then our torque is going to come out to be our force perpendicular multiplied by the distance. So this is going to be 3 meters times that 56.292. And we end up with our torque is equal to 168.88 Newton meters. And as around that, we have 2 sig figs in those questions, so 1.7 times 10 to the 2 Newton meters. Now we have to be careful with these units. You may have seen a Newton meter before. That's when we talk about energy in grade 11. Work is equal to force times distance. And if you remember, work is just, that would come out to be a Newton meter as well. We call this particular Newton meter a joule. So to be careful, these are, even though they have the same unit, they mean two different things. Because remember, on work and energy, the force has to be in the same direction as the displacement. For torque, the force is perpendicular to the displacement.